Hello everyone, I'm Nasumba Mary Vanessa, presenting a project about tax fare prediction. I worked with my colleague, Kato Collins. The contents of my presentation will include the introduction, supervised learning, unsupervised learning methodologies, dataset description, data preparation, and dataset splitting. In my introduction, in Uganda, there is a large population of about 25% that uses taxis on a daily basis. This is because most of the individuals do not have private means or cars. Therefore, there is a high demand of taxis, which has led to their increase in number, especially in the urban areas. We have come up with a tax booking and scheduling system to manage these taxis, in a more convenient and reliable way. The system will register drivers and their vehicles, thereby providing safety to customers, and it will also register the customers to ensure safety of their information. The data types of the problem will include distance, time, and prices. Then when we talk about supervised learning is a machine learning paradigm for problems where the data points are given labels. For our case, we shall talk about mainly two, which is regression and classification. Regression is a mathematical approach whereby we get the relationship between two or more variables. Therefore, basing on my project, I have a variable of distance, which is from the pickup point to the drop-off point. And there is also a variable time, which is the duration taken from the pickup point to the drop-off point. In this case, distance is an independent variable, while time is a dependent variable. And classification is the technique used to identify the categories of new observations on the basis of the training data set. In this, a program learns from the given data set and then classifies new observations into a number of classes or groups. For our case, we have distances can be our data set, and they can be categorized into short and long distances. Then for unsupervised learning, it's the opposite of supervised learning, where the data points do not have or are not given labels, and we shall use clustering and association. Clustering, it's like grouping of data points according to different factors or variables, which can include the distance, which factors can be, the factors we can use to cluster can be the size, the color, the behavior. And for our case, we can cluster data sets of a historical data taxi ride basing on their features. For example, the drop-off point, the time, and the distance moved. Then association is a rule-based machine learning and data mining technique that finds the relation between variables of various features. Therefore, to use association in text prediction, a data set of a historical tax rate is first analyzed to identify the frequent items that are mainly used. Then the items in the item set can be variables such as the pickup point, the date, the time, and the distances which are going to move. Then once the frequently used items are identified, association rules can be applied to them. Then the challenges we encountered while using supervised learning include the data quality. Here, if the data quality is poor, also the results the model is going to give will be inaccurate or poor. Yet we need our model to be more reliable and accurate. Then overfitting. Here it occurs when a model is too complex and fits the data too closely, resulting into poor performance on the new or unseen data. Here, it's like our data set will be biased in a way that it won't be able to work with new or data it has never seen before. Then underfitting is the opposite of overfitting. Underfitting is where a model is too simple and fails to capture the underlying patterns in the data. Then we have feature selection and unbalanced data. Then we have the challenges we faced while using supervised learning. Here we unsupervised story. Let's move on. Then here we had a challenge of determining the appropriate number of clusters. Remember, clusters are groups. So clustering involves grouping similar data points together. One of the challenges of clustering is determining the appropriate number of clusters, which can impact the performance or the accuracy of the model. Then selecting the appropriate distance matrix, dealing with the high dimensional data, then identifying the appropriate association rules to use. Then how did we reduce on some of the challenges we faced? We collected our diverse and unbiased data. This can help us to reduce on the inaccuracy, thereby our model making it more accurate since it will have learned or been trained from a variety of data. Then regularizing the model by adding penalty terms to the loss functions to prevent overfitting, or using simple models that are less prone to overfitting. Then adding more training data or adding more training data or generating synthetic data to balance the data set or avoiding underfitting. Here, if we add on more training, our data set won't be biased to only the data it has been trained with. It can work with also the data it hasn't been trained with. Then selecting and engineering relevant features such as the distance. Here we are looking at the features we're going to work with for our model. Then unassembling techniques to combine predictions of multiple models. Then when we think of a methodology, here we shall think of the problem we're actually wanting to work with, which is tax-fair prediction. Then we can look at the factors which we can base on to predict the fares. Then we can look at the distance moved, the location, the traffic conditions, and so on. Then how is AI going to address this? AI is addressing this problem by utilizing machine learning techniques or algorithms that can analyze that large data sets and identify the patterns and trends. These algorithms can be trained on historical data to learn the relationships between various features and determine the prices when applied to new data sets. AI can also incorporate real-time data such as traffic conditions and weather to make more accurate predictions. The methodology we are going to use here is linear regression, which is a statistical technique used to model the relationship between a dependent variable, which can be the fare we are going to pay, and then the independent variable, which can be it can depend on two or more, where our independent variables are the distance, time, and the location. In the context of tax fare prediction, linear regression can be used to estimate the fare based on the distance or the location we have moved to. Then the process of linear regression includes various steps, which can include data collection, the data we're going to use to actually train our model. Then data pre-processing, which includes cleaning and preparing the data for analysis. Here we can check for missing values, handling, removing outliers, and transferring the data if there is a necessity of it. Then model training. Here we are preparing the model to actually do its primary goal. Then model evaluation is assessing if the model can carry out its primary goal. Then model deploying is actually using the model to predict the prices on new data. Then dataset description. Dataset description here can be in a context of where we can know the size of the dataset, and it needs to be a large dataset, which can help us to increase on its accuracy. Since a small dataset, our model will overfit it. So, and overfitting is a problem. Then the quality of data, we talked about it. If the data is inaccurate, also the predictions will be not that accurate. Then the data relevance, is the data from a reliable source or it's just from some other source? Then the diversity of the data we have should cover different scenarios. Then we have the items, the variables in our data set, which can be the amount, the pickup point, the pickup longitude, the hour, the haversan distance, the passenger count, and so on. Then when we talk about data preparation and analysis, here we're preparing the data for the model to use it. So we have to check for various things, thereby removing duplicates, handling missing values, checking for outliers. And outliers here, we check the data set for any values that are significantly different from the rest. And outliers can have an impact, a significant one on our model. So it's important to identify and handle them appropriately. Then fix the data types. Data types can be like int, floats, the doubles, date or time, then feature engineering. Then feature selection. Here, we are going to use a correlation matrix, outlier plots, and box plots, and other things, not just only this, sorry. Then a correlation matrix helps to show the relationship among variables. And an outlier is an observation that lays a normal distance from the other values in a random sample. Then here we have a plot of our box plot. Then here we talk about the AI evaluation matrices, which may include the classification accuracy and algorithmic loss. Then when we talk about accuracy, comparing it with all the other three, accuracy is the ratio of correctly predicted observations to the actual predictions or observations carried out. Then recall is the ratio of the correctly predicted positive observations to the overall observations. Then precision is the ratio of correctly predicted positive observations to the total positive observations. Sorry. Then F1 score is the weighted average of precision and recall. Then here, our data set is split into three. The bigger percentage, we gave it to the training data set, which helps us to train our model to achieve its primary goal, which is tax fare prediction, sorry. Then the test set, which is used to test whether our model can actually predict. Then validation is where we check for errors and correct them. Then AI model selection and optimization. Here we shall talk about the support vector regressor, which is a type of supervised learning algorithm used for regression analysis. It tries to find out the best fitting line or hyperplane to map features to the corresponding continuous values by maximizing their margin, the margin between the close points and the regression line. Then we have the XGBoost, which is a machine learning algorithm that combines the strengths of multiple decision trees. And as it works, it progresses from one decision tree to another. It goes on improving the errors of the previous one. Then we have linear regression, which is an algorithm based on supervised learning, and it gives the target prediction value based on independent variables. Then we have AI model selection, which refers to the responsibility of individuals and organizations for their actions and outcomes. Here, our model was evaluated, and remember, evaluation was given 20%. And model evaluation refers to the process of confirming if the model really achieves its primary goal, which is, for our case, tax fare prediction. Then results and discussions. We will evaluate performance of evaluation of validation data sets. For this case, we shall use the mean absolute error and the mean root square. Sorry, for our case, we shall use the mean absolute error and the root mean square error, where the mean absolute error is the average error rate, which is the difference between the original and the predicted values, as you can see here. Then the root mean square error is the error rate by the square root of the mean of the MSE. And the smaller the root mean square error, the better the model. In my conclusion, after training and testing, the results show a fairly accurate model. We reach the conclusion that XGB XGBoost is the best because it gives more accurate values compared to the support vector regressor and the linear regression model. That is why XGBoost technique is the best fit for our model, as it has a low RMS root mean square error value. And these are the links to some of the data we use. Thank you for listening.